This is Geometry 7.2a. We're talking about similar polygons. As we learn about similar polygons, let's first talk about what do we recall from congruent polygons. Congruent polygons are going to have corresponding angles and corresponding sides that are both congruent. All the sides are congruent and all the angles are congruent of two different shapes. But when we talk about similar polygons, we'll have two polygons are similar polygons if corresponding angles are congruent. So that part's the same. The corresponding angles have to match up, but the corresponding sides are proportional. So an example of that is right down here, where you have a set of angles that are all congruent. So these are corresponding angles are congruent. But notice the side lengths are not exactly the same. But they're all the same multiple, and we'll talk about what the multiple is. There's a symbol that we use for similar, and that's a single squiggly line. We know that an equal sign, when we have the two bars, we mean equal. When we have a squiggly line with two bars, we mean congruent. So now when we have a single squiggly, that's going to stand for similar. And similar polygons will have corresponding angles that are congruent, but the sides are going to be proportional. That means the shapes can be different sizes, but they're just blown up versions of each other. The angles stay the same. When I zoom in, my shape looks much larger, but the angle is still the same. The angle doesn't change the value. And I zoom out, the side lengths are physically smaller, but the angle is still the same. Those are good examples of similar shapes. All right, so we're going to determine here if these two polygons are similar to each other. So we're going to look at different parts of them. We're going to start apparently with angle B. So angle B, we're comparing that with angle K. Angle B has one tick mark. Angle K happens to also have one tick mark. So K is congruent to B, or angle B is congruent to angle K. The third letters, should they match up? That should be a requirement. So C is congruent to L because they both have two tick marks. D is the last letter. D has three tick marks. That matches M. And then A happens to be the first letter which has, A has a right angle marker on it. So does J. So those angles are congruent to each other. So we have angles that match up, and it's in the same order as what we see in our statement above. So are the corresponding angles congruent? The answer is yes. So we have our first requirement. Corresponding angles are congruent. Now we have to look to see, are the sides proportional? What does it mean for the sides to be proportional? Well, we take our first two letters and we compare that with our first two letters. First two letters are AB, so that's 8. JK, so that's 14. I can reduce those both by 2 in this case, so that's 4/7. That 4/7 by itself doesn't mean anything. All the corresponding sides have to have the same reduced fraction. AD happens to be the first and the last letter. JM are the first and the last letter. So AD is 12. JM is also 21, which can be reduced, it looks like, by 3. So that gives us 4/7. Hey, we're on our way. We have 2 reduced fractions that show the same scale factor. CD is the last 2 letters. LM are the last 2 letters. So that's why we've made a fraction out of those 2. CD is 8. LM is 14. And it looks like we can reduce that fraction. And it also is 4/7. Then the final ones we haven't talked about yet were BC, which are the middle 2 letters, and KL, which are the middle 2 letters. That's why we set our fraction up using those letters, because they are in corresponding positions. BC happens to be 8. KL is 14. And that also can be reduced to 4/7. So we have the same scale factor, or the same reduced fraction for each one of these. Are the corresponding sides proportional? Because they reduce to the same ratio or the same fraction, the answer is yes. This common ratio is our scale factor. So our scale factor is 4/7. Write the ratios of the corresponding side lengths in a statement of proportionality. Statement of proportionality tells us how to do something. It's a specific process. It means it wants us to write the fractions using letters. They say right here, written with letters, not numbers. Written with letters. Statement of proportionality would probably go with the first 2 letters, AB, over the first 2 letters, JK. The second 2 letters, BC, over the second 2 letters, KL. The last 2 letters, CD, and the last 2 letters, LM. We still have one more to do. The first and last letter would be AD, and the first and last letter would be JM. So that is an example of statement of proportionality. It's a really big proportion. A ratio equals a ratio, which is the same as the other ratios like we showed up here. So what do we need to know to show if 2 figures, 2 polygons, are similar to each other? The corresponding angles are congruent. We have that. We notice that up here because the 1 tick mark went with the 1 tick mark, the 2 tick mark went with the 2 tick mark, and so forth. So we had that. And then through our calculations here, we had the corresponding sides were proportional. corresponding sides are proportional. We have to use the word corresponding sides because it's not all the sides. They're not all 5. But between the 90 and the 1 tick mark is 8, so between the 90 and the 1 tick mark is 14. Between the 1 tick mark and the 2 tick mark happens to be 8. And the corresponding side between the same type of angles is 14. Those are the ones that reduce to the same ratios. So let's look at this example. Are these two figures similar to each other? For them to be similar to each other, we need to first have congruent angles. We have a pair of 1 tick angles, followed by 2 tick angles, followed by 3 tick, and then 4 tick angles. So number 1, corresponding angles are congruent. We know that. The 3 tick angle is across from the 1 tick angle, and that's the same thing we have here. In the future, you're going to see the figure turned. The other figure might be turned, so it might not go in the exact same order or be pointed in the same direction. But what's across from each other and what's consecutive to each other is what's important. So what's the other part we have to check on? You check on the angles. What's the next part? The sides need to be proportional. So we have to do some calculations to see if we actually have that. All right, so between the 1 tick mark and the 2 tick mark, we have a length of 2. Between the 1 tick mark and the 2 tick mark, we have a length of 4. Well, that can reduce to 1/2. By itself, that doesn't mean anything. Between the 2 tick mark and the 3 tick mark, I have a length of 3. Between the 2 tick mark and the 3 tick mark, I have a length of 6. Hey, that also reduces to 1/2. We're getting somewhere. Those two match. Between the 3 and the 4, I have a length of 1. Between the 3 and the 4, I have a length of 2. That is the same scale factor. Awesome. And then finally, the last pair of sides would be 5 and 10, and that, of course, reduces to 1/2. So all the scale factors are exact, or all the ratios reduce to the same amount. So that would be our scale factor. Corresponding sides are proportional. On the flip side. Now, this one's a little bit different. This one has the symbol already. This one has told us that these two shapes are similar to each other. You don't have to prove that they're similar. We don't really have enough information. We don't know about the angles at all. So we don't have to prove they're similar. We're told that these two shapes are similar to each other. What is the scale factor? So for us to figure out the scale factor, we need to find out two sides that match together. So I would first look at FG. FG is 15. Well, here, let me be careful before I write that, because here's an example of what you just mentioned. This wants the scale factor of LMNP to FGHJ. They're going with the small shape to the large shape. So when we practice this out, let's use it in the correct order so we don't make a silly mistake. So we're going to start with LM, which is 12, over the first two letters, which is FG. If we reduce those, it looks like 3 goes into both of those. That's 4/5. By itself, that doesn't matter. They would all have to match that. But because we know they're similar, we expect them all to match that. And we can try it if we were interested in that. LP is the first and last letter. That's 16. First and last letter is FJ. That's 20. That reduces to 4/5. You're going to get the same reduced fraction with any pair of corresponding sides that you match up because they've already told you they are similar. So we have 4/5 as our scale factor from the smaller shape to the larger shape. LMNP, that's this one, with FGHJ, which is that one. Now, using that scale factor, they want us to find the value of x. So you could either use the 12 over 15 or the 16 over 20, but it's always best to use the smallest ratio of that. So we can use 4/5. That 4/5 should be at the same ratio as when we saw for x. Now remember, the 4 came from the small shape, the 5 came from the bigger shape. So when we start to look for our x, that came from the small shape, so that has to be on top of our fraction. That's MN, that's the middle two letters. GH is the middle two letters, so that's going to be 40. I can cross multiply. I only have to cross multiply in one direction. I don't need to multiply the 5 up to the x because then I'm just going to have to divide by 5 to get the x by itself. So just leave the 5 down there. Save yourself a step. 5 goes into 160. Let's see if we can do this without a calculator. How many times does 5 go into 16? It goes into it 3 times. 5 times 3 is 15. That means we have 1 left over to get to 16. How many times does 5 go into 10? So 5 is going to go into 160 32 times. You can take it into the 16 with a remainder of 1. You can put it into the 10. So you have 32. That's what our value of x would be. All right, in this next example, solve for the missing variable. Notice here, we know that they are similar. So we don't have to prove that they're similar. We know that they're similar. So the first thing we're going to look for is a scale factor. Find the scale factor. So to find the scale factor, we're just looking for 2 numbers on corresponding sides. So let's look at CB. It's always a safe one to look at first. CB looks like 7. First 2 letters are FE. FE, oh, FE is X. That didn't work. So let's go to the next pair. BA. BA is 6. ED. ED is 4. There it is. 6 and 4. We can reduce those, and we have a scale factor of 3 over 2. Now, it didn't tell us how we have to set this up, but as long as we're solving for a variable, it won't matter in how you set up the order of 4 over 6 or 6 over 4. You're still solving for the same variable. So we're doing the left shape compared to the right shape. So if we're going to solve for x, the x has to be on the shape that had the 4 in it. So the x is going to have to be on the bottom. And that's EF. EF is the first two letters. So that has to correspond with CB. CB was 7. So now we would need to cross multiply in both directions because your variable is on bottom. So that's 3x equals 14. Divide by 3, divide by 3. So x equals 14 thirds. You can leave it as a fraction. You could call that 4 2/3 or 4.66666. That would be fine. But 14 thirds is appropriate also. Solve for y. Well, we know we're in the same pair of triangles, so we're using the same scale factor. 3 over 2. The 2 came reduced from the 4, and the 4 came from the figure on the right. The y is on the figure from the right, so it has to be on bottom. Don't just put it on top, because that seems like a good spot to put it. It has to come from the same figure that your calculations came from. Y is FD, first and last letter. AC is 8. So we'll cross multiply and get 3y equals 16 divided by 3, and y is 16 thirds. 3 goes into 16 5 times with 1 left over, so 5 1/3. That would be fine. Or 5.333, that would be fine. You can just leave it as 16 thirds. All right, notice that these two triangles were not pointed in the same direction. The orientation was different, so it starts to get a little trickier on what's lining up. Well, we come over here and it's even trickier. These look like kites. We don't know exactly which pairs match with which pairs. So it's really important to use this is called a similarity statement. Use your similarity statement to determine what side you're going to work with. So first find the scale factor. First thing we're going to do. So I'm going to first look at MN because I know I have numbers there. MN is the first two letters. First two letters is RS. Hey, I have numbers there. So 18 over 30. Can that be reduced? It looks like 6 can go into both of those numbers. So 6 goes into 18 3 times. 6 goes into 30 5 times. So my scale factor is going to be 3 over 5. So to solve for the missing variable, let's solve for A. I'm going to start with my scale factor of 3 over 5. NP has my variable in it. NP is the middle two letters. That came from the same shape that had the 18. That is the smaller of the numbers. So that goes on top of the fraction. NP is the middle two letters. It has to correspond with ST, which was 25. That's going to go on the bottom of the fraction. And here we would need to cross multiply also. You could, I guess, multiply by 25 to get 75, reduce by the 5, or divide by 5, then solve. Whichever. But let's cross multiply, because that's typically what we do with proportions. That's going to give us 75 equals 5 times 2a minus 5. That is 75 equals 10a minus 25. Add the 25 to the other side, and we have 100 equals 10a. Divide by 10, and a equals 10. So 10 is A. Here's B. So we're going to start out with our scale factor of 3 over 5. The B is part of the larger shape, so we know that 3b plus 1 is going to be on the bottom of the fraction. TU is the last two letters, so that's from PQ. So PQ is 15. And again, we cross multiply. We get 3 times 3b plus 1 and 5 times 15. You should be thinking about what you would do next. Don't just sit there and copy me. You would distribute the 3 through to get 9b plus 3 and 75 minus the 3 minus the 3. That gives you 9b equals 72. Divided by 9, divided by 9. That should be 8. B equals 8. Now the last variable, if you've noticed it or not, the last variable is Z. It's up here as an angle. And what do you know about similar polygons? Similar polygons have congruent angles, not proportional angles. So don't use a proportion to solve for an angle. M should go with R. So if R is 115, we know that the measure of angle M is going to be 115. So those are your 3 variables we solved for. All right, last topic we will discuss for today. An altitude. An altitude is a side that comes down and is 90 degrees. You can draw it from any vertex. It doesn't matter which vertex you draw it from. A median goes to the midpoint, and it doesn't matter which vertex that this is drawn from. It would still be considered a median if it went from the vertex to the middle of the opposite side. What they want to point out here, right, this would be a median showing that they're the same on both sides. What they want to point out here is if 2 polygons are similar, that's what we've been talking about, then the ratio of any corresponding lengths in the polygon is equal to that same scale factor. So we come over here and we know these 2 triangles are similar to each other. So we're going to find the scale factor. First thing you want to do is find the scale factor. Now this is a little bit different. They're not giving us the whole length. Because this is a median, you know that it's cutting it in half. So you could use 96 if you want. But if we take half of it, that's the same proportion as if we took half of 80. Because 40 and 40 would make 80. You can use 80 and 96, or you can use half of 80 and half of 96. That's just fine. So we can use 40 over 48. I know that 8 goes into both of those. 5 and 6, so my ratio is 5/6. So if I'm going to solve for Km, I'm going to use that scale factor. Km came from the shape with the 48. The shape with the 48 is on the bottom of the fraction. So Km has to be on the bottom of the fraction. Don't mistakenly write it on top because you think all variables go on top of a fraction. It's got to come from the shape that you're looking for. Here's Km. And its corresponding side is the median that came from K. K is the middle letter, so we need the median that comes from F. Ah, it's right there. That's 10. So you can cross multiply to get 5 times Km equals 6 times 10, and divide by 5. So Km equals 12. We did it. That was a lot. Good job, everybody.